we've talked about a lot of different parts of software development, but one of the things we haven't really talked about is what the best way to create good working code is. Now, ultimately, you will get user stories. You will turn the user stories into tasks. You'll sit down in front of your laptop and you'll start to crank out code. Fantastic. That's great. Now, the code that you create is either good code or bad code. Hopefully, it's as good as you can make it. It probably has some bad in it. It matters finding out what parts of the code don't work and then fixing it. That's cool. So how are you going to go about doing that? Well, testing is a good way to do it. We've talked a little bit about testing and stuff like that. What we want to do today is talk about something called test-driven development, which is a philosophy that says, listen, if you want to produce really good code, what you need to do is develop your code with testing in mind. It makes it easier for the testing and it makes it easier for you to produce good code. So let's see how we go about doing this. Alright, so we talked about this at the tail end of our last class. So in the real world, if you were to go out and get a job today, in most software development shops, you're going to discover that there's actually 3 different groups that do 3 different types of testing. The first type is what we call unit testing, and as a software developer, you are the person who's responsible for doing unit testing. Unit testing says, this is my code. I have a set of requirements. I've made changes to my code to implement these user stories. I claim that my code works correctly, all by itself. I'm not talking about anybody else's code, I'm just talking about mine. That's called unit testing. And as a software developer, you are probably on the hook to develop your unit test cases. So there's a whole set of test cases that run against your code and verify that your code does both what it's supposed to do now with all your changes and a whole bunch of test cases that you've developed over the last year or 2 years that test it to make sure that you didn't break anything that it already did. Right? Cool. All right, well, that's good stuff. So you're on the hook for that. When you're all happy with your code, you hand your code off to the system testing group. And they take your module, they take my module, and they take modules from other people, and they put them all together. Congratulations, now they have a system. And then what they do is they test the system. And the inputs to the system flow through your module and my module, and stuff happens. And then outputs flow out the other side, and the system testers verify that that actually happens. What they're basically doing in our world is they're testing to make sure that your module talks to my module takes the data that you give it correctly, processes it, and then does something else with it. Okay? So system testers aren't looking specifically at your module, but they are looking at what your module does in relation to everybody else's. And if there's a problem on the system testing level, they will sit down and they will go, okay, so that's not what we were expecting. Whose module is at fault? So that they can come back to you and say, listen, we're getting bad output. We think something's going wrong in your module. Take a look and figure out what the problem is. Now, the final set of testers are what we call user testers. They're people who basically play the role of the end user, right? So they get the beautiful, wonderful, shiny product just before it's getting ready to be shipped, and they sit down and they try and do all sorts of stuff with it. They play the role of the world's craziest user. They put in stupid inputs. They hit things at the wrong time. They click on things. They dump bad data files in. They get confused about stuff. Basically, they're trying to run through everything that the user could possibly do to the software to see if they can cause it to break. Okay? So these 3 sets of testing, basically that's all the testing that gets done in a piece of software. If it can pass all 3 of these, the company's going to say, fantastic, it looks like it's good enough, let's ship it. Okay? Python, interestingly enough, has 2 different testing tools that are available to you. One's called unit test. Surprise, it does exactly that. So it does testing on a unit test basis. What it's looking for is an automated testing framework, okay? It allows you to test a very specific piece of your code. Unit test is a concept that's available in a whole bunch of different languages. So these types of tools are available no matter what language you have to be doing stuff with. You can use fixtures, you can do test suites, and you can do a test runner. Basically what unit test is designed to do is provide you with a tool that allows you to do automated testing of your code. That's cool stuff. In this class, we're not going to sweat it. We're moving on, we're learning more stuff about Python. But potentially in the next version of this class, this will be actually a very cool tool for you to spend time with. If you like unit test, you're going to like PyTest even better, because it's a bigger testing tool. It's a little bit more mature and stuff like that. What they're interested in doing is giving you the ability to, once again, add test cases to the code that you already have. But this PyTest allows you to have less of a framework, so you can just sort of drop testing statements into your code. It's actually very cool stuff. It integrates with a lot of other testing tools, and it's been out there for a while. There's a lot of plugins and customizations that you can do for it. So if you were developing a Python code for like a real world product, you could actually use one of these two products to test your code. To develop a suite of test cases, you apply it to your code, and you be sure that your Python code, before it went out the door, actually worked correctly. So what would a PyTest script like for homework number 1? Well, you remember homework number 1, and you remember where we were encrypting the social security number. It looks something like this. You might not look exactly like this, but this is basically the gist of it. These 2 lines down here effectively are PyTest lines. It says def test encrypted _ SS. So basically we gave the test case a name, okay? And then here goes, assert encrypted SS equals, and then a particular string. So encrypted SS is the string that we were calculating. We're figuring out what the encrypted SS looks like. What we're saying is that this one equals that particular value. Assert is a PyTest command that says, hey, I say that this is something that is correct. So PyTest would come along, it would verify that this was actually true at this point in time in the code. If that's true, congratulations, your test passed, you move on. If this was not true at this point in time, PyTest would throw an error. It would say, whoa, wait, something's wrong, and it would flag this as an error. You get an error message in your test output, and then you go back and figure out what was wrong there. Make sense? So you'll be able to just put these kind of commands throughout your code and make sure that what's going on is what's supposed to be going on. So we now move on to what we call continuous integration. So remember, software isn't just you go off into a closet, you crank out some code, you immerse in the closet, and you hand off your code to somebody else. It's a continuous process. So today I did some of the pieces, almost like your homework, right? In the first hour, you did some of your homework. Second hour, you did some more of your homework. Third hour, you did some more of your homework. 8th hour, you got closer to being done, right? So basically, it's a developing process. So the same concept goes along with integration and testing. Version control keeps track of the code. Now we've got automated tests. So we've got 2 powerful tools. We've got a piece of software that's keeping track of our code, and we talked about all the powerful integrated testing tools that we have. If we bring them together, we get close to something called continuous integration, which says when I check my code in, when I say, hey, this code's done, I'm going to put it into my configuration management system, we can automatically fire off the automated tests and run some tests against that code that we just checked in to make sure that it actually works correctly. So we can compile the code, we can run the automated test, and then we can do display or mail out reports. What it means is that if you've introduced errors into your code, you'll know about it very, very quickly. Because you check the code in, and like a half an hour later, you get an email that says, by the way, there's some errors in that code that you just checked in. That's what continuous integration is. All this is going on behind the scenes. It's all automated. You actually don't have to do anything. It just occurs for you. A little picture of continuous integration in action. So here's Bob. Bob's going to go ahead and check some of his code into the server. When he does that, automatically behind the scenes, the version control code notifies the continuous integration tool. Hey, I've got new code. Okay? Continuous integration code, the tool goes, oh, got new code. What test cases are affected by that code? Okay, it comes up with a list of test cases. So I'm going to go ahead and check out the new code. I'm going to compile it, and then I'm going to run all the test cases that are impacted by that code. I'm going to run them against them and make sure they still work. Okay? And I'll either create like a web page or else I'll email something to the team when those tests are done, and I'll say, by the way, all tests passed. The code that you checked in is good. Or whoa, we've got some issues. The code that you just checked in needs to go. You have to go back and fix some stuff with it. So Bob doesn't even have to think about this anymore, right? He checks his code in, and the system will automatically verify that he's got good code. That's exactly what the computer's responsible for. How many tests do you need? Because we've talked about creating tests, but how many do you actually need? The answer is it's not really a number thing. So the question is, how much code do you test versus the chances of finding a bug? So you have test cases that test all of your code, every path in your code. In a perfect world, absolutely yes. We don't live in a perfect world, so the odds are no, you won't. There will be portions of your code that don't get tested before you ship it. Okay? All right. So now you're going to play a little trade-off game. Okay? You want to test the important parts, and if something doesn't get tested, then hopefully it's not a terribly important part. You don't want to have a whole bunch of test cases that test the same part of the code, because who cares, right? Have one test case that tests one part of the code and move on. You don't want to focus on the number of tests that you have. I've got 100 tests, I've got 1,000 tests. Oh, you must be doing a really good job. No, stop. What's most important is what we like to call coverage. So how much of your code is actually being tested? Okay, we'd like that number to be as high as possible. In the real world, what we're really looking at, probably somewhere between 85% and 90% of your code gets tested before you ship it. What that means is 10% to 15% won't be tested before it goes out the door. That's generally where all the errors show up. Because that's the way life is. Okay, so good software needs to work. We're comfortable with that. How do you actually know that your software works? Well, even with unit testing, there's a possibility that a portion of your code is going to be untested. Okay, but here's an interesting idea. What if testing was a core part of how you actually developed your code even before you started writing code? You know, instead of having testing be something that you go back afterwards and do, maybe if testing was something you thought about before you even did your code development, it would make life easier for you and your testing inside the house. What if everything was done with testing in mind? Version control plus continuing integration plus automated testing, these are all powerful tools. If you could bring them together to cause you to create better software, it sure seems like the world would be a better place for everybody. So here's the new idea. Test first, don't test last. Don't write your code and then come up with some test cases, which is traditionally the way things are done. Instead, the new idea is to stop. Let's think about your test case before you write the code.
So like, think of where it's going to fail before you write it.
Yeah. Well, it's interesting. If you think about a test case before you write it, you think that's going to have an impact on how you write your code.
You're going to write it specifically with the test.
That's exactly right. Got it? Yeah. So you're going down exactly the right path. If you write your test case before you write your code, when you develop your code, you're going to be thinking in terms of the test case, right? And so it's going to change. The most important part on that, if there's something that's not in the test case, are you going to write code for it? Probably not, right? And that's a huge breakthrough, okay? Because we produce a code that does this, and does this, and does this, and which is fine, and it's lovely functionality. But if we don't have a test for it, we'll never know if that functionality is correct. So if you do your test case first, then all of a sudden your mind becomes almost like a laser. Okay, I need to create code that does this functionality, because that's what the test case does, right? You end up just developing that functionality, which is fine. That's great, because you have a test case for it. Well, it really, truly does. Now, by the way, maybe you need that other functionality. Fantastic. So then you create a brand new test case for that other functionality, and then you code it, right? So you're right on board on that one. Don't try to go back and work testing into a completed project. Instead, what you really want to do is you want to build support for it right off the bat, okay, from the start. The new idea is what we call test-driven design, or if you're really cool, you just refer to it as TDD, okay? And this is sort of a new concept that's going through the software world, but it says basically create the coding with testing in mind from the start. Now remember, this is one of our user stories. Remember Pay with Visa, MasterCard, and PayPal, and we broke it up into 3 tasks. So if we go all the way back to here, this is the right time for us to start to think about testing. We haven't done any coding on this yet, right? So test first. So with this particular user story, we want to break it into tasks. We know about that. If we're going to break it, if we're going to test it first, then we need to take a look at our first task. Okay? If we jump right in and create the code, then we'll be right back to where we were. So before we start cranking any code for this Pay with Visa task, we need to stop, take a step back. You got to say, okay, great. How am I going to test that? When I actually do have code, how am I going to test it? Good question. Okay. So if we think about the Pay with Visa feature, what's it actually going to have to do? Well, let's think through what this design is going to be. We're going to have, there's going to be order information, right? If somebody's paying with their Visa card, they have to place an order. Okay? So we're going to capture the customer's name, what they're ordering, and the cost. Every time you order from Amazon, those are 3 things that you have to put in, right? We're going to have to represent the credit card information. Okay? When I actually pay with my credit card, there's 2 pieces of information they're going to need. The credit card info and the secret card number, right? Okay? And then finally, we're going to have to represent the receipt information. So when we've completed the transaction, we need to provide the user with a receipt for what they just did. And so we'll have to capture the confirmation number that came back from Visa, well, the final cost, and of course the date of the transaction. Cool, so we're sort of thinking through our design at this point in time. What's interesting is our plan with the design is to apply it to the test case first, and code second. So now we'll create the test case. Okay, so we're going to write the test case first. We'll start with the order information part of the task. Remember, represent the order information. And then we're going to use our test framework to create a test for the pay with Visa functionality. Okay, so welcome to the world of TDD. When you're creating test cases before you write the code and then letting those test cases drive how you create your code, that's what we mean by TDD. Okay? I create my test case first, and after I have that test case, I then go ahead and create the code. It's a formal term that's used to describe the process of testing from the outset of development. It means that you write every line of code specifically as a response to the test case that you created. Right? So now your code is being driven by your test. I would argue that your tests are being driven by your tasks or your user stories, or your code's actually being driven by the tests. So how do you write a test case? Okay, so your first step has to be determine just exactly what needs to be tested. In the case of the Visa thing, we have to make sure that we enter the order information. We have to make sure that we get the credit card information. And after the transaction is done, we have to make sure that we get back from Visa all the important information that confirms what we just bought, right? Okay? We need to determine what the smallest test that you could write would be that uses the order information that you'll be storing as part of the first task. Now this starts to become critical. Because remember, I'm going to place an order using a Visa card. What are the things I have to do? Your mind starts to expand. Because there is a lot of stuff potentially that you have to do there. What we're saying with the test case here is keep it small.
So like the very first thing you would probably do is make sure you're collecting the name.
So what do I need? I need the name. I need to know what they're actually going to buy.
Yeah.
An item number, and then probably the cost. Right? I mean, so those are the three things you sort of need. So that would be definitely what your very first test case would be. Right? Now the second test case might be get credit card number and get secret number. But notice that's a separate test. It's not just one where get the information what you're going to order and get the credit card number. You don't put it together. You break it up in multiple tests. You have no code because you're writing your test first. There's no way that this test should pass the first time that you run it. So you have your code, you have this test case. If you run that test case against the code, what's the test case going to do? It's going to fail because you ain't got no code there, right? That's exactly what you want to have happen. There's no question about this sort of stuff. Probably won't even compile if you compile your test case, but that's okay. You want your test case to fail miserably right off the bat because you've got no code. It's testing something that doesn't exist yet. Congratulations, you're doing things in the right order. Okay? Rule number one, your test should always fail before you implement any code. If it passes, then you're doing things out of sequence. Okay? You want your test to fail when you first write them. The point of the test is to establish a measurable success. And because your test is failing, now it's clear what you have to do to make that test pass. So when you're developing your code after you've already developed your test case, the whole purpose for developing that code is to get that test case to complete successfully. Okay? So now you've got a new goal for when you're coding. I want my test case to run correctly. Once again, what we're doing here is we're scoping down. We're limiting exactly what your code's going to do. And it's going to prevent you from putting a lot of extra, wrong way to say it, fluff into your code. Your code is going to be laser focused. It's going to do just exactly what it has to do to make sure that that minimal test case passes, which is great. That's exactly the way you want to develop code. All right, the simplest code to get this test to pass is called, in the vernacular of the industry, getting your tests to green. That green doesn't look very good, but the reason they call it getting tests to green is because most automated test systems use a bar system to show you how successful you're being with your test. If you have any of your tests that are not actually successfully passing, they will put a red bar up. If your test passed, then they'll actually go ahead and put a green bar up. So your goal is to get your test to the green bar. TDD rule number 2, implementing the simplest code possible to make your test cases pass. Right? So once again, you're starting to see that we're writing minimal stuff here. We write the smallest test case possible to just test a single function, and then we write only the code that's needed to get that test case to pass. Right? We're starting to understand that we're focusing. We're not trying to do a lot of frills and stuff like that. We will go back and we'll add the frills, but we'll add test cases that test the frills before we do that. Okay, there's the Yanni principle. Okay, test-driven development is about doing the simplest things that you can in order to get your test to pass. Don't add anything that you might need in the future. Alright, because remember, we're only adding the code that's being tested by that test case that you already wrote. Okay, if you do need something in the future, you just write another test case for it. Okay, we'll cross that bridge when we get to it. Focusing on small bits of code is key to test-driven development, and Yanni means you ain't gonna need it. Arguably, a lot of code that gets implemented potentially never gets executed. You're worrying about conditions and cases that will actually never occur. So by using the Yanni principle, what happens is you'll circle back and you'll implement it if and when you need it. But most importantly, you'll write a test case for it before you implement it. 3 steps to test-driven development. Number 1, very first step is, of course, your test is going to fail. You write a test to check whatever functionality you're going to do is going to fail because you don't have any code. You're testing code that doesn't exist, okay? Call it the red stage because your GUI will probably show a red bar. Not passing the test. Now you move to the green stage. This is where you actually put in the code, but just the code that you need to get that test to pass. You write the simplest code possible, nothing extra, and this is called the green stage. Because now when you run your test case on your big master control center for all of your tests, you should have green bars as far as the eye can see. Okay? Now, after you get this done, you can refactor, go back in and clean up stuff. So you can get rid of duplicated code, ugly code, old code, all this sort of stuff like that. But you do that after your test passes. Okay? After you get this all taken care of, go on to the next, write your next test, create your next bit of code. So, if we're going to do an exercise to pay with Visa, okay, so representing the order information, we have to capture the customer's name, what they're ordering, and the cost. The question is what kind of tests could we create for the order information task? If this is where we were starting, start by using for a task, and we were going to write a test before we wrote any code, what would our test have to test? What kind of information are we going to get from the user?
Name, order, what order is the cost.
Cool, fabulous. All right, so that's 3 pieces of information. What would we expect a name to look like?
That was a little strange.
So sort of strange. So we're going to, would we assume that it would have more than 0 characters?
Yes.
Okay. Now we're going to say there's some sort of limit on how long a name can be. Seems that there should be, right? I mean, admittedly, people can have pretty long names, granted, okay? But they're not infinitely long, right? So we need to put a pencil down there somewhere. Now, what can actually go into a name? What could I build a name out of?
Characters, no numbers.
Characters and no numbers. Can I have upper and lowercase?
Yeah.
Okay, upper and lowercase. Can I have symbols? Careful. Careful.
Few.
Careful. So there are some symbols I can have. What symbols can I have in a name? Hyphens, 1. Apostrophe?
Apostrophe, maybe.
Do you think?
I knew someone with
Does somebody have apostrophe in their name?
It's apostrophe, S-O-N.
Rock and roll. Okay, what else could we have? Well, hyphen, we're good with that. What else? I can think of at least one more. What's that?
Like accents?
You know, that's right. So that's a good point. If we have any sort of international, non-US based names, okay, that's cool. Yeah, that's good. We want to go to Cyrillic or anything, that sort of stuff. But yeah, no, you get the gist of it. That's a good one. What else? How about a period? Right, we can always have periods. It could be doctor or something or other, or there could be junior or senior. I think you can also have a period with them. All right, so that's pretty good with the name. What they're ordering. So how would how would they specify what they're ordering?
Probably do like the order number, like the number of.
Maybe a catalog number?
Yeah.
Okay, and you would assume that a catalog number has some sort of format. 3 characters followed by 4 digits or whatever. Okay, something like that. So we should double check to make sure we can handle that. And then of course the cost, right? So cost we would assume would be in US dollars of some sort. What's the smallest amount that you could order from a cost point of view?
1 cent.
Nope, close up. Sure.
Oh.
It could be free, right? Could be.
Oh, yeah.
Okay.
You can buy stuff for free.
Now, of course, it does bring up an interesting question. You know, like, what's the most expensive thing you could order? What's the most expensive thing you could order from Amazon?
Let's
find out.
Let's
find out.
What?
So yeah, you know, it's probably a Google search or something like that. I mean, 10 grand or something like that, maybe 100 grand. I'm not quite sure what the story is. I don't think you get anything below $1 million off of Amazon, something like that. There's got to be some sort of upper limit to that one, though, right? So okay, so that's all. Basically, can you see us putting together some sort of test for this? I guess we would be ordering products, right? That was second through.
I was gonna say, whatever the top cost could be, just the total of all the products.
So that, you know, I'd like one of everything in your catalog, right? everything. Okay, cool. Okay. So we can you understand how we put together tests? Tests. Mind you, we've written no code. Now we put together tests. We're going to exercise the name. We're going to double check and make sure that all the little characters can go into the name and stuff like that. We talked about catalog numbers, so we'll make sure we have the right format of the catalog number and stuff like that. And then we'll also test, numbers. We'll take all sorts of different numbers as far as quantity, from high to low to 0 to all that sort of stuff like that. Now we go write our code, and the test is what's going to be in our head, right? We're going to make sure that we collect all the information from the user, and we filter out anything that doesn't meet that criteria. In test-driven development, test drive your implementation. So all the way through development, by writing the test before the code, you have to focus on the functionality right off the bat. When we created our input test case, if we went off to write the test case, we would be thinking about our test case as we wrote our code. Okay? And the question is, what is the code that you're creating supposed to do? And the ability to focus on the test case gives us the ability to focus on what the things are supposed to do. Good habits. Each test should only verify one thing. You need to verify two things? Great. Create two separate test cases. Avoid duplicate test code. If you have test code that tests on a given piece of functionality, don't write another test code to do it. You already have that one taken care of. Keep your tests in a mirror directory of your source code. What you start to discover is, I might have a lot of tests. Yes, your tests effectively come out to be a whole other batch of source code. I'm a software developer. I write Python software. Congratulations, software developer. You also write test cases, which means that you have to manage and keep track of those test cases. Okay? Keep your tests in separate subdirectory on the same level as your source code, and this makes life easier for you in your build scripts. Completing a task, you have all the tests that you need, and they all pass. When your task passed, move on, and different tasks, use the same process. Boom, boom, boom. Write your test case, write your code, verify that it works, move on, move on, move on. All right, what did we cover today? Test first, not last. The mantra of test-driven development. TDD rule number 1, your test should always fail before you implement any code. If it passes, something horribly, terribly wrong is going on. And TDD rule number 2, implement the simplest code possible to make your test case passes. So don't make code this big, make it as focused as possible. Only implement the code that you need to get that test case to pass. And then move on and write another test case for more functionality. That's it. That's all there is to test-driven development. So when you encounter it in the real world, you go, oh yeah, I remember that. All right, what are we going to be covering next time? The second part of test-driven development. That'll be exciting. And that will occur when? After spring break. You'll come back with empty brains, and we will pour this into it. Fantastic. Okay, we're going to talk about Python. Today we're going to be talking about processing strings, because we're going to spend a little bit of time after this talking about homework number 2. Let's take 10 minutes and come back. So I will see you back here at 5 till.